All right. So we want to solve equations with radicals. And basically what a radical is, it's just like a square root, right? So what happens if we have the square root of x plus 1 plus 3 equals, let's say, 14, huh? And I want to solve for x. Well, basically what we want to do is we want to solve for x, right? And so I know I'm going to need to get rid of the square root, the plus 1, and this plus 3 right off the bat. And what I want to do is I want to take care of everything so I can isolate this square root by itself. Well, look at the plus 3. He's hanging outside that, so he's kind of easy pickings, right? So I'm just going to subtract 3 from both sides. And now what do I have left? X plus 1 equals 11. Now, what I don't want to do here is say, okay, well, I can just do the same move, right? I want to get rid of this plus 1. I can subtract 1 from both sides. That's a dangerous move, right? Because that plus 1 is protected underneath that square root. So how do I get rid of the square root? Well, just like all of mathematics, I mean, why did I subtract a 3 here? Well, because addition by 3 and subtraction by 3 are opposites. So what's the opposite of square rooting? Squaring. So when I square a square root, these two things are like equal and opposite forces, and they kind of cancel each other out. So all this side becomes is x plus 1. And this side becomes 121. So now I'm going to subtract 1 from both sides, and I'm going to get x equals 120. Now, these equations are no different from other ones. I can check my answer quite easily. Let's say 120 is the answer, huh? So the square root of 120 plus 1 should equal 14, correct? So that means the square root of 121, plus 3 should equal 14. The square root of 121 is 11. Hey, 11 plus 3 is 14, right? So it's good when these things work out and you don't feel like an idiot at the end, right? There's a couple little things that can that I've noticed kind of give students pause on these is if you have ones that look like this, square root of, let's say, 2x plus 1 minus 1 equals 11. Okay. So I've got this equation, same thing. I want to get this square root alone. So who's hanging outside the square root? I got this minus 1 and 3. This is basically like the situation like 3x minus 1 equals 11. What would I do first in 3x minus 1? I'll write that like normally, right? Like this. I would add 1 to both sides, and then I would divide both sides by 3. Well, guess what? That's exactly what we're going to do here. My first step is I'm going to add 1 to both sides, and I get 3 square root of 2x plus 1 equals 12. Well, now I have this, I'm multiplying by 3, so I'm going to divide this side by 3 and divide this side by 3. And so what I have is the square root of 2x plus 1 equals 4. So same move, now I'm to the square root. I'm going to square both sides, and I get 2x plus 1 equals 16. And kind of out of room here, so I'm going to take this and bring it all the way up here. So 2x plus 1 equals 16. And I'm off the side on that side. So I want to subtract 1 from both sides, and I get 2x equals 15. I'm going to divide both sides by 2, and I'm going to get x equals 15 halves, or 7.5, or however you want to do it, right? So the key thing about this one is that number out in front, there's nothing there. It's like, what's it doing? I can't just subtract it, right? That's a multiplication right there, so just make sure you divide. Here's the weird case about it. The question is, what number would I have to square root so I'd get a negative 3? If I put a 9 in here, the square root of 9 is a positive 3, right? So I could try putting a negative 9 in here. Maybe that will give me negative 3. Try it on your calculator. You're going to get something that, like an error message. You can't ever take a square root of a negative number. Square roots of negatives just don't work very well. And it kind of goes back to what they mean, right? For something to be the square root of 9, it would mean like some number would have to be able to multiply by itself to get to it. Well, what number multiplies by itself to get to negative 9? Would negative 3 times negative 3 work? No, because a negative times a negative is also a positive. And a positive 3 times a positive 3 wouldn't work because that would get me a positive 9 as well. You would almost need a half of a negative, right? So half a negative would equal a full negative. In mathematics, you'll get there eventually. That's called an imaginary number, right? It's half a negative. We're not going to worry about those right now. Okay, so for us in solving equations with radicals, we have the square root of, let's say we have the square root of x plus 4, something like this. Well, we're going to do all of our moves just like we did before. Add the 1, and I'm going to get 2 the square root of x plus 4 equals negative 6. I'm going to divide by 2, divided by 2, and I'm going to get the square root of x plus 4 equals negative 3. So it's at this step right here where theoretically I would square both things that I need to kind of check. If I'm squaring a negative over here, I immediately say that's a no solution. That's a no solution situation. It's very easy to go blow by this point. This point tells me no solution, right? It's very easy to blow by this point and just say, well, then this is x plus 4 equals negative 3 times negative 3 is 9. And you would get a solution here of 5. Right? So you could go by here and get a solution. The only thing is your solution doesn't work. To kind of prove it to you, I'll just plug in a 5 here real quick and let's see what we get. So I'm going to get 2 equals the square root of 5 plus 4. And that's what we got, so it should work just like the first one. So that's 2 times the square root of 9. Square root of 9 is really just 3, right? Hey, 2 times 3 is just 6. 6 minus 1 is 5. Does 5 equal negative 7? Sadly, not. Right? So that's kind of proof that solution that you can get sometimes doesn't necessarily mean it's a solution.